So here's another task that involves both file input and output. And in this one, we're going to read numerical input using fscanf and then generate basically string output to a different file. So the goal is to read an input file that contains these pairs of numbers, one pair per line, where each pair corresponds to a 24-hour time. So 13:15 would be 1:15 p.m., this would be 5:10 p.m., this would be 6:10 a.m. And then actually this one right here would be midnight, due to the very strange way that our clocks work. So we can argue about that in some other setting, come to the office hours, I guess. But our goal for today is to take these times and generate them in this formatted 12-hour representation. So 6:10 would become 6:10 a.m., 13:15 would be 1:15 p.m., 12:01, that's 1 minute after noon, that would be strangely 12:01 p.m., and then midnight would be 12 a.m. So this is a nice task, I think, because it gives us some exposure not only to reading files, but to doing something legitimate with the data in them. We're actually going to have to write a few cases to handle all the different ways that this could go together, which I think is a good idea because often we get stuck doing these contrived examples where all we're doing is reading data and then dumping it into some other file. Okay, so I've already written the code to open the input and output files. So there's my input file, times.txt. We've actually seen this in a previous example. And there's my output file, 12hourtimes.txt. And just like in previous examples, I am testing to make sure that fopen returns a non-null value. If fopen returns null, then I'm done. I can't continue the program because the whole point of the program is to work with files. Unlike previous examples where I typically use this as my condition, if input file equals null, instead I'm using this sort of condensed notation. Now, as usual, you're welcome to keep saying this. There are reasons why this actually can be helpful. It's maybe easier to understand what's going on. But this is a piece of notation that a lot of C programmers get into pretty quickly, and you tend to see this quite a bit in C code. It's dense at first, but there is something sort of natural about it. And basically, it's because when I open my input file, I expect either a valid result or that the input file is if it can't be opened, that it comes back as null or that it's invalid. And I mentioned in an earlier video that when we talk about pointers and their relationship to true and false, the null pointer, which is never valid, which never points to anything valid, is always considered to be equivalent to false. And every other pointer, every valid pointer, is considered to be equivalent to true. That means if I write if not input file, what I'm asking is if input file evaluates to false. In other words, if input file is null. So I could write this. You don't have to, but you probably have to get used to seeing it because we likely are going to be seeing this in future examples. Okay, same thing for the output file. I check for the errors in opening it. And now at the bottom, of course, I've already written my fclose statements to make sure my files get closed. So what I want to do first is I want to write a loop that reads these pairs of, I guess we'll call it hour and minute values. So I guess what I'll do is I'll read them. It seems like int should be sufficient for this. So I'm going to call them hour and minute. And then I'm going to write a loop that calls fscanf. So my loop will call fscanf to read two int values. I want to read the entire pair. I don't want a \n in there. I want to make sure I give it my input file. You might have noticed in every video I forget to put input file as my first argument to fscanf. If you get weird random compiler errors about fscanf, check that you've done that because it seems to be an easy thing to forget. And then I want to read my hour and my minute. And I have to provide pointers to those things. Okay, so I expect fscanf to have read two things. And so I want to keep going as long as it successfully reads both of those things. And then the question is, what do I generate to my output file? And I think the way I'm going to approach this, I think there's probably four cases. So certainly there's at least two cases. Is the time before noon, so is it AM, or is it afternoon, or PM? So I think certainly there's that, and I can figure that out by testing whether the hour number is at least 12. Every hour that's 12 or above is in the afternoon. So I'll start with that case there. Okay, so if hour is greater than or equal to 12, okay, so then I'm in the afternoon, PM. Otherwise, I'm in the morning. Now, there still might be some issues with, like, what do we do about midnight, which is technically 12 a.m. We'll worry about that a little bit later. First, we'll see if we can get most of the times during the day, so 6:10 a.m. or 1:15 p.m. working. So if the hour is greater than or equal to 12, then I guess the hour is either equal to 12 itself, which means we're sitting at noon, or it's something larger than that. So I guess I'll write that as like, e.g. 13:10 or 17:10, something like that. If this is my hour, if I'm looking at 1 p.m. or later, then to print it in a 12-hour representation, I want to subtract 12 from the hour. I want this to not be 13, I want it to be 1. I don't want this to be 17, I want it to be 5. So I think because I've written the if statements the way I have, it might be as simple as writing hour equals hour minus 12. And then I want to print to my output file. Okay, so I print to my output file. The time would be %d, and then I'm going to use %2d. 02d will make sure that it prints. I don't want to end up when it's, let's say, 6:04 p.m. I don't want it to get printed like this. That looks really, really weird. What I want is 6:04. And you can tell printf, you can force it to always use 2 digits and to put a 0 in the extra digit by using %02d here. So that's what I'm going to do. Okay, and then this would be PM because I'm afternoon. All right, and then I provide my 2 numbers, hour and minute. Okay, so that's one case. Now, what if it's in the afternoon, but it's actually noon? So let's say it's 12:15. Well, I don't want to subtract 12 from that, so this would be, 12:15. In this case, it's just 12:15 p.m. It's not 0:15. I only subtract 12 on a 12-hour clock if it's 1 p.m. or later. So in this case, I think I'm good to just write it like this. Now, this is one of the reasons, if you can see, we're going to end up with 4 different cases. It's really important that we go back later and make sure that somewhere in our input file, we are testing all of these 4 cases. Okay, so I just print the time exactly as normal. I don't subtract anything. And it might be, if you cared enough about this, I would say for an assignment you wouldn't worry about it. You might notice you could go back later and you could restructure these if statements to save you a bit of duplication, because this is exactly the same as this. And so you could maybe move them outside the if statements. I'm going to leave it for now. I think that's a good idea, maybe if we refactor the code later, but for now let's just get something working. Okay, so what if we're in the morning? Well, if we're in the morning, there's still a special case, because if the hour is 0, we don't want to print that as actually 0. We want to print that as 12 a.m. And so in this case, I would say if the hour equals 0, so this would be, 00:15, 15 minutes past midnight, which we want to print as 12:15 a.m. So in this case, I'm going to write a print statement that just prints 12. I'm not even going to bother changing the hour value. So in this case, it's 12 something a.m. and then I just print minute. You could also just set hour to equal 12. And now otherwise, if I'm looking at an hour of the morning between 1 and 11, then I just print it normally. I don't need to subtract anything from the hour value. So I would print the hour and then the minute to 2 positions a.m. and then I print hour and minute. All right, so I'll just skim through what I have here to see that I think, everything. We notice that in the while loop, the incrementation part of the loop is just happening in the continuation condition because fscanf, if it succeeds, will have updated the hour and minute values. So I think I might be done. Let's just make this a bit bigger so we can see everything at once. We'll try compiling it. Let's take a look. Oh, it's complaining about on line number 64. This is a tough one. When you write complicated printfs, it's easy to make this mistake. What printf is reading here is it's saying, okay, wait, %02a? What the hell is that? And it's interesting because %a is actually a valid format specifier. It just does something weird. So the warning it's giving is, okay, wait, you want like a double or something? What I've done is I've forgotten the %d. I likely would have noticed that if I tried running the code, but we'll just fix that there. So %02d and then am is just text that I want to come afterwards. One other way around this, if that's bothering you, because I know it can be really cryptic to look at statements like this, you don't have to write everything in the same printf statement. You could do separate printf statements to print the hour, the minute, and am or pm. That would be perfectly valid. It might even make the code a little bit easier to read because you could split it up into more pieces. Okay, so we'll try that. I just added some new lines there because I noticed that they were missing, and that would have resulted in pretty ugly looking output. And then we'll try running it. It generates no output to the user, but we don't really expect it to. And then we go up here and we open our output file. And there it is, so 6:10 a.m. In fact, why don't we compare it side by side with our input file? So 6:10 is 6:10 a.m., 13:15 is 1:15 p.m., here's 5:10 p.m., here's 6:07 p.m., There's 12:01 p.m., so 1 minute past noon, and then there's midnight. So it looks like we have it. Although it wouldn't hurt to add a couple more test cases, especially of the noon and midnight situations. Let's try 12:59. Let's try let's do 0:18. And just make sure that it catches up in all cases. So we run this. This we have to, let's just close it and reopen it because sometimes the text editor doesn't catch up to the changes very quickly. So remember that because of the way Jupyter Hub works, when you run a program that modifies files, you may have to close and reopen the files or hit refresh in the file browser for it to catch up with the changes. It should refresh itself in a few seconds, but it doesn't. Often you can get impatient, and I don't blame you. Okay, so 12:59 would be 1 minute before 1 p.m. And it looks like that worked. And 0:18 would be 18 minutes past midnight. It looks like that worked as well. So it's always good to do a bit more testing in cases like this, but we have at least made sure to test all of the 4 cases that we found ourselves in inside our loop.